In this question, a parallel plate capacitor is charged to potential difference of V volts. After disconnecting the charging battery, the distance between the plates of capacitor is increased using an insulating handle. As a result, the potential difference between the plates. So here in this particular case, let us assume there is a parallel plate capacitor. So area of both the plates is A, and distance of separation between the plates is, let it be, D. And here in this particular case, the plates are these two plates are initially charged. Initially charged means, suppose here we are connecting these two plates to an external source. We are just connecting them to an external source as shown in figure. So let over here, this is higher potential and this is lower potential of the cell. So that means this is positively charged, this will be negatively charged. And finally, when the key when we are applying some potential difference, let the potential difference over here is V. That means these plates will get charged, clear, and it will get charged till the potential remains same. So let us assume that as the upper plate of the capacitor is connected to the positive terminal of the cell or battery, so that means this will get positively charged, and the lower terminal will get negatively charged as it is connected to the negative terminal of the battery. That means you will get an electric field in between the plates, as well as a potential difference will be created. So here in this particular case, what it is saying is that the capacitor is charged to potential V volts. So right now it is charged to potential V volts after disconnecting the charging battery. So here in this particular case, what we'll do, we'll disconnect the charging battery. That means this will not be connected, clear. So if it is not connected, then what will be the new system over here? So here assume that this is the system. That means we are taking, so right now it is disconnected from the cell, clear. So if it is disconnected from the cell over here, assume that we are disconnecting. So let me just erase this one. This is now disconnected from the cell. So what it is saying, after disconnecting the charging battery, the distance between the plates of capacitor is increased. So here in this, initially the distance between the plates is D, and right now we'll increase the separation between the plates. Suppose these are right now they are separated by a distance of, let it be, D prime, and here in this particular case the condition is that D prime is greater than D. As a result, the potential difference between the plates. So what about the potential difference? Initially the potential difference is V, and finally over here what will the potential difference? So as we can see, we are not changing the area of cross-section. Both are means area of cross-section of both the plates will remain as it is. So here in this particular case, so thing is that what will the potential difference? So here if we just check the capacitance, clear. So what will the initial capacitance of the capacitor? It will be epsilon naught A by D, as the capacitance of parallel plate capacitor depends upon the shape and size of the capacitor plates. So it will be epsilon naught A by D. So here in this particular case, what will the capacitance? Let the capacitance be C prime. So it depends upon the shape and size. That means it will be epsilon naught A by distance between them is D prime. So here in this particular case, we can see there is a change in the capacitance. What the change? As we are increasing the distance between the plates, then capacitance will decrease, because there is an inverse relation between them. That means over here, what will happen is we are increasing the distance between the plates, then capacitance, new capacitance will be less than the original capacitance, clear. New capacitance will decrease. Okay, new capacitance decreases, then what about the charge, clear. So right now assume that these two plates are charged. So this one, upper one will be positively charged by Q, and the lower one will be negatively charged by Q, clear. So equal amount of charges are present on the both the plates of capacitor. That means after disconnecting, there will not be change in the charge. So charge will remain as it is, clear. चार्ज यहाँ पे उतना ही रहेगा. डिस्कनेक्ट के बाद क्या होगा? बिकॉज दिस कैपेसिटर इज ऑलरेडी चार्ज टू some it already charged by Q amounts, clear. तो अभी इसमें चार्ज क्या है, Q है, दैट मीन्स दिस Q विल रिमेन कांस्टेंट। Q यहाँ पे क्या होगा, कांस्टेंट होगा। क्लियर, Q कांस्टेंट होगा, कैपेसिटेंस डिक्रीज हो रहा है, तो पोटेंशियल में क्या चेंजेस होगा। सो वी नो दैट देयर इज अ स्टैंडर्ड रिलेशनशिप बिटवीन दिस थ्री एंड दैट व्हाट दैट रिलेशन इज Q इक्वल टू C इंटू V, और यू कैन से P इक्वल टू Q अपॉन C. So here in this particular case, as Q is remaining constant and capacitance is decreasing, then what will happen, the potential will increase. The potential difference between the plates of the capacitor will increase. So here in this particular case it will increase. So let us just understand this particular question by going through a simulation over here. So what the simulation will tell us, here in this particular case we can see where initially when we are applying zero voltage or potential. Clear, so there is no potential difference across the plates, it is zero over here, voltage is showing zero. Clear, so but capacitance is how much, capacitance is 0.30 picofarad. Clear, so here in this particular case right now we'll apply some potential difference. That means we are giving some potential. As we are increasing the potential, then charge stored across the plates is increasing. Clear, so here you can see charge is increasing. Clear, energy stored across the plates is also increasing. Clear, so right now suppose if we'll keep the potential up to 1.5 volt. Clear, and how much that means as soon as we are applying the potential of 1.5 volt, within a fraction of a second the capacitor will get charged and till what potential it will achieve, it will be having the potential same as the potential of the source. Clear, source का जितना potential है उतना ही यहाँ पे हमें मिलेगा. Clear, सो बिकॉज दैट इट कैन बी द मैक्सिमम पोटेंशियल. अगर मान लो कि बैटरी का पोटेंशियल हमें और थोड़ा ज़्यादा मिलता, तो ये पोटेंशियल यहाँ पे ज़्यादा हमें मिल सकता है. ओके, सो हियर इफ इट इज़ द केस, then according to the given question, suppose if we'll increase the separation between the plates. Okay, here separation after disconnecting the system. Right now what we'll do, we'll disconnect the system from the battery. Clear, so still amount of charge is how much, still right now here the amount of charge or charge present on the plates is 0.444 picocoulomb. Clear, when we connect them, same charge, after disconnecting charge is remaining constant, no change in the charge, and also potential difference is constant if there is no change in the distance of separation between the plates or no change in the area cross section. एरिया प्रोसेशन और डिस्टेंस में अगर हमें चेंज नहीं करना है, तो डिस्कनेक्ट करने के बाद भी हमें प्लेट्स के बीच में, कैपेसिटर प्लेट्स के बीच में जो पोटेंशियल डिफरेंस हमें उतना ही मिलेगा, 1.5 वोल्ट. क्लियर, बट सपोज हियर इन दिस पर्टिकुलर केस इफ आई विल इंक्रीज द डिस्टेंस ऑफ सेपरेशन फ्रॉम 6 mm टू लेट इट बी 8 mm. अभी डिस्टेंस ऑफ सेपरेशन कितना है, 8 mm किया गया. क्लियर, तो कैपेसिटेंस भी डिक्रीज हो रहा है. क्लियर, कैपेसिटेंस में चेंजेस आ रहा है, बट चार्ज में कोई चेंजेस नहीं आ रहा है. चार्ज हमारा नहीं, यहाँ इस वाले पर्टिकुलर हाँ चार्ज में उतना ही है. अगर आप यहाँ पे देखोगे क्लियर, इस वाले पर्टिकुलर में जब हम 6 ले रहे थे, जब हमारा 6 था डिस्टेंस ऑफ सेपरेशन, चार्ज कितना है 0.4 पिकोकुलम, 44 पिकोकुलम, एंड कैपेसिटेंस इज 0.30 पिकोफैरेड. सो बट व्हेन वी आर इंक्रीजिंग द डिस्टेंस ऑफ सेपरेशन टू 8 mm, जब हम इसको 8 mm कर रहे हैं, तो कैपेसिटेंस 0.22 पिकोफैरेड आ रहा है. पहले 0.30 था, बट चार्ज अभी उतना ही सेम रह रहा है, देर इज नो चेंज इन द चार्ज. एंड इनिशियली देर वॉज ए पोटेंशियल डिफरेंस ऑफ 1.5 वोल्ट, बट अभी कितना मिला है हमें पोटेंशियल डिफरेंस यहाँ पे 2 वोल्ट मिल रहा है. दैट मीन्स हियर इन दिस पर्टिकुलर केस एज वी आर इंक्रीजिंग द डिस्टेंस ऑफ सेपरेशन बिटवीन द प्लेट्स, capacitance is decreasing, charge is remaining constant, and potential difference is increasing. Charge is remaining constant, why? Because it is disconnected from the source. सोर्स से हम उसको डिस्कनेक्ट कर रहे हैं. क्लियर, सिमिलरली अगर हम डिस्टेंस ऑफ सेपरेशन को अगर कम करेंगे, मान लो कि पहले 6 था, 6 के बाद अभी हम इसको 4 करेंगे. क्लियर, वी आर मेकिंग इट 4. सो व्हेन वी आर मेकिंग इट 4, कैपेसिटेंस इज इंक्रीजिंग. क्लियर, कैपेसिटेंस यहाँ पे अभी 0.44 पिको फैराड आ गया, पहले 0.30 था. क्लियर, और वोल्टेज अभी कितना है 1 वोल्ट आ रहा है. क्लियर, अप्लाइड पहले अप्लाइड कितना था 1.5 वोल्ट, अभी कितना आ रहा है, डिस्कनेक्ट करने के बाद अभी पोटेंशियल डिफरेंस हमारा डिक्रीज हो रहा है, कैपेसिटेंस यहाँ पे इंक्रीज हो रहा है, और चार्ज में कोई चेंजेस नहीं है. क्लियर, सो दिस इज how we can see that if here in this particular case what the question is saying is that
if we disconnect the charged capacitor, and after that if we'll increase the distance of separation between the plates, then what will happen to the potential will increase. So option A will be the correct one.